This lesson shows how to graph rational functions with holes. Since division by zero is not defined in algebra, a rational function is not defined for the zeros of its denominator. For this example, the denominator polynomial is x plus 1. So the zero of the denominator is x equal negative 1, since at x equal negative 1, you can see the denominator is equal to 0. So a rational function is not defined for the zeros of its denominator, and these are called points of discontinuity. A point of discontinuity can either be a vertical asymptote or a hole. Notice both of these functions have factors of x plus 1 in their denominators, so they both have zeros at x equal negative 1. For the first function, x equal negative 1 is a zero only of the denominator, so the function has a vertical asymptote at x equal negative 1. For the second function, x equal negative 1 is a zero of the denominator and the numerator. In this case, the function has a hole at x equal negative 1. To see why this is a hole, notice when x doesn't equal negative 1, the factors of x plus 1 cancel out, and the function is y equals x minus 2, a line that looks like this. So the rational function is the same as the line, except at x equal negative 1 where it's not defined. In order to show where the function is not defined, you draw a hole or an open dot on the graph of the line at that point. Here's the first of 3 examples of graphing rational functions with holes. Begin by factoring the numerator. Since the denominator has a factor of x plus 2, x equal negative 2 is a zero of the denominator. Since this is a zero of the denominator and the numerator, the zero is a hole at x equal negative 2. To graph this function, simplify the expression by canceling the common factors of x plus 2. The result is y equals 2x minus 1. So graph this line. Next, evaluate y equals 2x minus 1 for x equal negative 2, the location of the hole. This gives 2 times negative 2 minus 1, which is negative 4 minus 1, and that equals negative 5. So the function has a hole at negative 2 comma negative 5. Draw an open dot on the graph of the line at that point. For the second example, begin by factoring the numerator and denominator. The factor of x plus 1 gives a 0 at x equal negative 1. Since this is a zero of only the denominator, x equal negative 1 is a vertical asymptote for the function. The factor of x minus 1 gives a 0 at x equal plus 1. Since this is a zero of the denominator and numerator, x plus 1 is a hole for the function. This function has a vertical asymptote and a hole. To graph the function, simplify the expression by canceling the common factors of x minus 1. This gives y equals 2 over x plus 1. Then graph this rational function. Next, evaluate y equals 2 over x plus 1 for x equal 1, the location of the hole. This gives 2 over 1 plus 1, which is 2 over 2, which is 1. So the function has a hole at 1, 1. Place an open dot on the graph of the function at this point. For the third example, begin by factoring the numerator. Since the denominator has a factor of x minus 3, there is a 0 at x equal plus 3. Since this is a 0 of the denominator and the numerator, the 0 is a whole at x equal plus 3. To graph the function, simplify the expression by canceling common factors of x minus 3, and you get the equation of a horizontal line y equals -2. So draw the graph of the line and an open dot on the line at x equals 3. Remember, factors define zeros. So when a rational function has the same factor in the numerator and denominator, the graph of the function has a hole at the point defined by the factor. This lesson showed how to graph rational functions with holes. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.